Next, let's look at number 20 from section 3.1. Here we have another table, but we're going to have to fill the values in. So we're asked to construct a 99% confidence interval. So first of all, let's just stop right there. That, of course, means 100 minus 99 is 1, so my significance level alpha value is 0.01. 0.01 is the equivalent of 1%. Construct a 99% confidence interval for a population proportion using repeated tests of significance to develop an interval of plausible values based on a sample proportion of 0.52. That means my p-hat statistic is 0.52. That I'm going to need for the count box. And my sample size of 300, that would be n equals 300 to put in the applet. Use two-sided tests with the following values under the null hypothesis to find the corresponding p-values to construct the interval. So you're going to want to go to the one proportion applet, and what I did is create a screenshot here. So the first null hypothesis value in the table is pi equals 0.44, so that's what I'm going to put into the probability of success in the applet. And the sample size n is 300, and in general we take 1,000 samples, and make sure you have proportion of successes selected, and you draw the samples, and then the extreme as we want greater than or equal to 0.52. That's what we said was the p-hat value that goes in the count box, the statistic. And notice that the two-sided box is checked. And when I did this, I got a p-value of 0.004, right? So this is my p-value, 4 out of 1,000 in the two tails. And when you do it, you might get something slightly different. But I have here 0.004 as my p-value, and since that is less than my alpha of 0.01, let me see if I can squeeze this in a little better. My p-value is 0.004, which is less than 0.01, which means my null hypothesis value is rejected as not plausible. So FYI, this reject or plausible applies to the H0 value, the value of pi in the null hypothesis. It doesn't apply to the p-value. We don't say the p-value is plausible or rejected. We're talking about the value for the parameter that's in the null hypothesis. Okay, next one, let's do 0.48. So I'm going to go to the applet, and now that I have everything in there, I can just change the probability of success to 0.48, and you can see I've already done this, and once you have it set up for the first one, the next ones go very quickly. Everything else stays the same, sample size 300, 1,000 samples, 0.52 in the count box, two-sided selected, and I get a p-value of 0.152. So I'm going to put 0.152, and this, of course, let me write it the other way, is greater than 0.01, our significance level. So that means this value of 0.48 is a plausible value for pi. And let's do pi equal 0.59 as our next one. So back to the applet, the only thing I have to change is the value in the probability of success, and we're going to do 0.59. And as soon as we draw samples, then the computer automatically, the applet will compute that new p-value, so everything else in the applet stays the same. And now I have 0.013 as my p-value. Was I doing 0.58 or 0.59? I forgot. 0.59, that's what I thought. So 0.013, which is less than that is not less than, 0.013, of course, is bigger than 0.01, so that makes a plausible value of 0.59. That is a plausible value for pi. So you should continue with the applet and do the rest of these. Again, each time you're just going to change the value in the top box of the applet to whatever's in the H0 column of this table. You're going to write down the p-value, two-sided p-value, and compare that to 0.01, and then decide whether to reject, whether you reject or fail to reject that null hypothesis value, and based on that, you'll calculate the 99% confidence interval. So I'm going to stop the video here, and I will post in Blackboard the table all filled in with the result of the confidence interval.